Hello everyone, this is lesson 5 and today we're going to talk about LEDs. In this lesson, you will learn how to change the brightness of an LED by using different values of resistors. So let's go through the required components for this lesson. The required components include 1. A Arduino R3 board, a 5mm red LED, a 220 ohm resistor, a 1K ohm resistor, 10K ohm resistor. We'll talk more about the resistors later on in this video. And then we will need 2 M2M wires, also known as male to male jumper wires. And then lastly, we need a breadboard. So now let's introduce the components. Component introduction. Alright. So first, let's talk about the breadboard. So a breadboard enables you to prototype circuits quickly and without having to solder the connections. So for example, in here, this is the R3 board. So this is the breadboard included in the super starter kit, and we'll use this as an example. Let's move this, and then let's take a screenshot of this that we can put in. Oh, bad screenshot. Like this. Alright. Then we can put this in here. So this is a breadboard. And then breadboards can come in different sizes and configurations. The simplest kind is just a grid of holes in a plastic block. Underneath the plastic are strips of metal that provide electrical connection between the holes in the shorter rows. So what this means is that, let's add another picture in here. So something like this. This is the back of the board. So between every single column here, there is metal underneath that makes it conductive. And then over here, so these 2 long columns, so these are connected all the way through. And if you, let's say, put a wire through this end, then all of the holes are now connected to this hole. Alright, and then pushing the leg of 2 different components into the same row joins them together electrically. A deep channel running down the middle indicates that there is a break in connections. So in the middle, there's this deep, so over here, this break is kind of important. The rows, it breaks up the rows. So in here, you can see that these 2 metals are not connected. There's a break in connections, meaning you can push a chip in with the legs at either side of the channel panel without connecting them together. So you can put a chip on one side of the legs or on this side and the other on here, and that way you can put it on without making the two sides touch electrically. Additionally, some breadboards have two stripes of holes running along the long edges of the board that are separated from the main grid. These have stripes running down the length of the board inside and provide a way to connect a common voltage. They are usually in pairs of plus 5 volts and ground, or plus 3.3 volts and ground. Oh, volts, what, doesn't need an E here. These stripes are referred to as rails, and they enable you to connect power to many components or points in the board. So up here, this is what they're talking about. It means that they want us to put positive 5 or 3.3 volts of energy in through this, and then the ground should come out through the negative end here. Same thing on top. You can make one side plus 5 and the other 3.3 volts. Alright, and one more thing to note, while breadboards are great for prototyping, so like the first draft, something like that, they have some limitations. Because the connections are push fit, meaning you can just push the connections in without having to clip or solder, they are temporary. They are not as reliable as soldered connections. If you are having intermittent problems with a circuit, it would be due to a poor connection on a breadboard. Alright, so this is a breadboard, and there aren't just these types of breadboards. There are maybe some smaller ones like this one, and some even smaller ones. For example, this one. This no longer has the rails on the sides, they only have the columns. And then there are some other ones that have some stickers on it. And these ones, for example, there's a break on the two really long columns, and that means you can connect a voltage here and another voltage here, and they won't be connected here. There's a break in the paint and the lines, as you can see. Yeah, so these are some different types of breadboards. So after breadboards, let's move this over a little. So after breadboards, we have LEDs. LEDs make great indicator lights. They use very little electricity, and they pretty much last forever. In this lesson, you will use the most common LED, a 5mm red LED. 5mm refers to the diameter of the LED. Other common sizes are 3mm and 10mm. You cannot directly connect an LED to a battery or voltage source because 1. The LED has a positive and a negative lead and will not light if placed the wrong way. And 2, an LED must be used with a resistor to limit or choke the amount of current flowing through the LED. Flowing through the LED. Otherwise, it will burn out. So let's include a picture of the LED. Alright, let's get rid of all these breadboards. And then, so this is a LED, like this, or like this. These are what I was talking about, the most common 5 millimeter red LEDs. And over here, we have a 3 millimeter green LED. Alright, let's include a picture of one of them in our notes. Let's include this one. So as you can see, this wire is longer than this one. So there are 2 ways to tell which is the positive lead of the LED and which is the negative. So first, the positive lead is longer. So if we see here, this lead is longer than this one, so that means that this side is positive. This side and this side is negative. And the second way, normally people just use the first way. The second way is the negative lead enters the body of the LED. There is a flat edge to the case of the LED. So we can't really see this on video, but supposedly this part is a little flatter than the rest of the circumference of the LED case. So like the plastic surrounding the LED itself. This part, the negative end, is supposed to be a little flatter here. You can see with the naked eye, but on film it's not that easy to see. Alright, and additionally we have resistors. As the name suggests, resistors resist the flow of electricity. The higher the value of the resistor, the more it resists, and the less electrical current will flow through it. We are going to use this to control how much electricity flows through the LED and therefore how brightly it shines. So let's see, so a resistor looks like this. Like this. Let's take a screenshot. Oh. Like this. Alright, and then let's talk more theory. The unit of resistors is called the ohm, OHM, which is usually shortened to a symbol. So we might need to insert ohm. So this sign, which is the Greek letter omega, because an ohm is a low value of resistance, we also denote the value of resistors in another omega sign, ohm, k ohms, which is 1,000, and m ohms. So 1,000,000 ohms. and these have names. These are called kilo ohms and mega ohms. Kilo ohms and mega ohms. In this lesson, we are going to use 3 different values of resistor. Now, try to remember these. There's a 220 ohms, a 1 kilo ohm, and a 10 kilo ohm resistor. So these resistors all look the same, except that they have different colored stripes on them. These stripes tell you the value of the resistor. So let's include a chart. It's good to know this. There's 2 types of resistors. There's a 4-band and a 5-band. So the 4-band is normally like less accurate than the 5-band, and normally the resistors are shown using a 5-band code. So from the left to the right, the first one is the first digit, second one is the second digit, third one is the third digit, and there's a multiplier. So these 3 digits, 1, 2, 3, multiplied by 1, 10, 100, 1,000, and so on. And the last one is the accuracy or the tolerance of the resistor. So for example, this one right here, the first band is yellow. So let's see, the corresponding color is yellow. So 4, and then orange is 3. So 4, 3, a black, so 0, 4, 3, 0, and multiplied by 10. So 4,300, and a tolerance of 1%. Tolerance is good to know, but it's not that important, so we don't really need to look at it. Now let's look at our resistor here. So this is red, red, black, black, brown. Red, red, black, black, brown. Alright, so now let's look at our code. So red is 2, second red is 2, so 2, 2, 0. So red, red, black, black, brown. So 2, 2, 0 multiplied by 1, which is nothing. 2, 2, 0, 220 ohms with 1%. So this is the first one I was talking about, a 220 ohms. So remember that as red, red, black, black, brown. Next, we have a resistor that is like this. So on here, this is, let's look at it this way. It's brown, black, black, brown, brown. So it's black, brown, brown. Wait, no, it's brown, black, black, brown, brown. So brown is 1, black, black, 100, multiplied by 10. So it's 1,000. So this is a 1 kilo ohm resistor, 1,000. And lastly, come back to our film. Lastly, we have this type of resistor. This is a brown, black, black, red. So brown, black, black, red. Brown, black, black, red. So 100 multiplied by 100. So that would be 10,000. So 10k ohms, which is 10 kilo ohms. Alright. Now, this way is kind of hard, and we need a chart, or unless you remember it, which good luck, there's quite a lot. So unlike using LEDs, resistors do not have a positive and negative lead. They can be connected either way around. If you find this approach method too complicated, you can read the color ring flat on our resistors directly to determine its resistance value, or you may use a digital multimeter instead. So we can use a multimeter to showcase these again. So let's move these out of the way for now and bring in our huge multimeter. So this is our digital multimeter, and then we can turn it to ohms. So first one is, let's move it to 200, and let's measure our 220 ohms. So let's attach these onto here. It doesn't matter which way is positive and which way is negative. And let's see. Alright, why is this on 200? Let's move it to 2K. So now we can see this is 217/16-ish, which is basically 220. 216/15. So this is within tolerance. And then after 220, let's try our 1K, 1000, 1 kilo ohm. So this is 997/98-ish. This one is also quite accurate. Alright, and lastly, our 10,000 ohm. So let's connect both ends. And then this is 10,000, so we need to move it up to 20K, not 200. Well, that's too high. 20K, and we can tell this is 9.7, which is basically 10. So 10,000. Alright, and this is another way to see how high the resistors are. Alright. And then, so this is a package of resistors from our Super Aligu kit. And you can see it labels how high the resistors are. And that's a good way to know at the start. And also, the three normally used resistor amount is just 220, 1,000, and 10,000. So you can just make their arms a different length. So you can make both of them long and one short, or both of them short to denote how long they are. This can also be used. And I like to use this way so we don't need to read the bands or anything when we are making prototypes. Alright, now let's include a diagram of how we're going to connect it onto our Arduino R3 board. So like this. So we go from the 5 volts, we add a resistor to an LED and go to the ground, and then change the 220 out for 1,000 or 10,000, depending on how much we need. And then we can include a visual like this. So now let's build our circuit. So let's use this mini one. Alright, and then connect the 5 volts, which is 5 volts, and then connect this to the ground like this. And then now we can put like this, add a resistor here, add a resistor like this, and then we can add an LED. Be careful which side is the long side. So this positive like this, and then connect it back to the ground. So this is a really simple circuit. We go from the positive 5 volts, come here, and then go through the resistor. From the positive side of the LED, go in, and then go out through the negative side, and then comes to this wire, and goes back into the ground. So let's connect this to a power source and see. So this is really bright. The whole LED bulb is lit up because the resistor is the smallest resistor yet. Alright? Now we can take out this resistor and change it to a 1000 ohm or 1 kilo ohm resistor, like this, and then move like this. So now the positive end goes through the resistor, positive side of the LED, and then goes through the ground back in. So now we can try this. So now the last one was the whole case lit up, but now this one is more subdued and only this part of the LED is lit up. And then now let's try the 10,000. So 10,000 is 2 short ends. And then let's add this on like this. So again, positive goes through, positive end, and then ground. So like this. So now we can see it's barely lit up. You can kind of see it, but when we tilt it like this, you can barely see it anymore. Yeah, so we can see that 10,000 is way too large for normal applications of the LED. Alright, so now that we've tried all three, it's your chance to try them. I will assign that as the homework. So here, homework, heading 2, and then complete all 3 experiments and take a picture of them. Alright, and that's the homework. Thank you for watching and see you next class.